Welcome back to the deep dive. Our mission today is pretty laser focused. We are cracking open everything we can find on OffsideAI's new platform, PivotalAI V2.1.
And we really do mean everything.
Yeah, we have a mountain of sources here. We've got the marketing pitch deck, the product briefs, even some of the internal architectural notes.
That's right. And this isn't just, a minor patch or some small feature update. The material we're looking at, it positions the December 2nd, 2025 launch as a fundamental shift in how enterprise teams create architecture and code.
Exactly. The core promise, the thing that immediately grabbed my attention, is this trifecta of capabilities they talk about.
Workflow automation,
Agent design.
agent deployment.
Right. But the absolute headline, the bold claim OffsideAI is making, is that this is the, and I'm quoting here, first agent-native enterprise workflow automation platform.
It's a huge claim.
It is.
And that term, agent native, that's really the key we need to turn here.
What does that actually mean in practice?
Well, when you hear that phrase, you need to understand they're not just talking about slapping a large language model on top of Excel.
Okay.
They are fundamentally restructuring the entire platform around this idea that the design itself, so the flowcharts, the diagrams, all that visual stuff.
The stuff we draw on whiteboards.
Exactly. That stuff is no longer static documentation. It becomes an executable code foundation, and it's maintained and manipulated by AI agents.
So we're not just integrating a chatbot. We're building an environment where the agent is the primary translator, I guess, the executor of the design.
That's the perfect word for it. And this goes directly to the problem PivotalAI is trying to solve.
Which is that massive friction point.
The massive, costly friction that exists right now between that high-level visual thinking, the brainstorm, the whiteboard session, and the low-level, technically rigorous execution of writing production code.
Precisely. You have the architect sketching this perfect system on a whiteboard, and then what happens?
Then a DevOps engineer spends days, sometimes weeks, manually translating that sketch into hundreds, maybe thousands, of lines of Terraform or Kubernetes YAML.
And that gap, that design to execution gap, that's where everything falls apart.
It's where budgets just explode, where timelines die, and I think most importantly, it's where architectural drift starts to set in. The code just rarely matches the diagram for very long.
That disconnect is the central tragedy of modern software development, isn't it?
It really is.
So the core goal of this deep dive, then, is to get past the marketing hype and really understand the mechanics. How does PivotalAI actually eliminate that manual translation step and keep everything in sync?
Well, it achieves this by fundamentally unifying the workspace.
Okay.
The visual artifacts, the diagrams, the flowcharts, the data visualizations, they stop being these passive byproducts. They become what the sources keep calling first-class citizens.
First-class citizens. I love that concept.
It means they're the source of truth, they generate the underlying code, and crucially, they synchronize with that code in real time.
So if I change a component on the diagram,
The associated infrastructure as code changes automatically, instantly.
wow. So they're not just pretty pictures you print out for a meeting. They are the living foundation of the product.
That's it. And this leads directly to the platform's operating mantra, which is really central to their whole philosophy.
Which is,
Think visually, act technically.
think visually, act technically. I like that.
It really encapsulates the whole paradigm shift. We're moving from documenting execution after the fact, which is always reactive and full of errors.
To designing the execution itself visually,
Mm-hmm.
which is proactive and generative.
Exactly. The goal is to move the user, whether you're a product manager or a DevOps engineer, into a higher state of abstraction. You start worrying about what the architecture should be, not how to write the required syntax for it.
Okay, let's unpack the specific pain points that this platform is designed to fix. The OffsideAI analysis, it breaks down exactly where teams are just bleeding time and suffering from this context-switching nightmare.
Yeah, the source deck details 4 critical areas of friction, and they all revolve around using disconnected tools.
So let's start with the data layer.
The first area is data analysis. The core issue here is that most data analysis, it still happens in these very specialized, siloed tools, or, let's be honest, in sliced spreadsheets.
Right.
You might have the raw numbers, but the spreadsheet itself is static. It's dumb. It has absolutely no AI context.
So what's the consequence of that? What happens when there's no AI context?
The consequence is that the tool can't understand the relationships or the intent or the business context of that data. It doesn't know that column C is your active user count and that it's linked to deployment region alpha.
So you're stuck doing everything
You
manually.
were stuck. You have to export it, clean it, manually translate it into a query language just to ask a sophisticated question. The tool doesn't bridge that gap between what a human wants to know and how the data is structured. It's a massive time sink.
And the second point, visual design. This is where we see that classic problem diagrams that have nothing to do with the actual code. We've all been there.
Oh, yeah. This is the design to build gap, just writ large. You spend hours making this beautiful, detailed diagram in Lucidchart or Miro.
It looks great in the meeting.
Looks fantastic. But the moment a developer pushes a new commit or a cloud resource gets changed, that diagram is instantly stale.
It becomes a historical artifact.
Exactly. It needs a manual update, but because documentation is always secondary to deployment, it quickly becomes misleading. It actively encourages that architectural drift we were talking about.
So if I'm hearing you right, the fundamental flaw is that all the time you invest in creating that visual design, it's basically throwaway work. It has zero enforcement power over what actually gets built.
Precisely. And that leads us straight to the third friction point, which is, I would argue, the most painful one for technical teams.
Infrastructure.
Infrastructure.
This is the manual translation into HCL or YAML. For our technical audience, we all know what this means, but let's talk about the specific challenges that come from that manual process.
I mean, this is more than just syntax. This is dependency hell.
Right.
You spend hours sketching out this robust cloud architecture, an EC2 instance connected to a private subnet, linked to an RDS database with specific security groups, accessing an S3 bucket.
And then you spend just as long, or longer, writing hundreds of lines of HCL, managing all the dependencies, defining attributes, checking syntax.
And you have to manually track state management and remote backends, which are just fundamental complexities of production Terraform. That whole manual translation, it completely breaks the creative flow from whiteboard to cloud. And it's so intensely prone to these silent, hard-to-debug errors.
That friction is why provisioning a new environment can take days instead of hours. And the last point, which everyone hates and is the ultimate sign of disconnected tools.
Documentation.
The worst.
It's the lowest value, highest effort task there is. Just endless, inefficient copy-pasting into reports and wikis.
So actually you've built the architecture and written the HCL. You have to spend even more hours taking screenshots, summarizing data, dragging diagrams that you already know are outdated into a PDF for an executive.
The source deck really hammers this point. Hours are lost manually translating flowcharts into logic and whiteboard sketches into infrastructure. All of that is just extremely expensive engineering time wasted.
So to synthesize this, the problem isn't just that we have separate tools, it's that the input from the creative phase, the visual stuff, is treated as this passive information that has to be laboriously recoded for the execution phase.
Yes, that's the chasm, and PivotalAI is designed to be the bridge over it.
So how is that bridge built?
Their solution is this seamless four-step transformation process that keeps teams moving forward without all that context switching.
What are those 4 steps?
They are ideate, visualize, generate, and deploy.
Okay, so ideate is the brainstorming and data gathering. That happens in the data grid, which we'll get to. Visualize is the active diagramming.
Exactly. Visualize moves you from the raw data and ideas into a concrete diagram, whether that's a business process or your cloud setup. But the crucial agent-native shift happens at step 3.
Generate.
Generate. This is where the visual diagram isn't just saved as a JPEG. It is instantly used to create the actual production code, whether that's Terraform HCL for infrastructure or Mermaid syntax for your workflow logic.
The diagram is no longer just an artifact. It is a code template.
Precisely. And finally, deploy,
Good.
which finishes the cycle by pushing that generated code out through secure, defined channels. The key distinction here is that if the diagram is the code foundation, you eliminate that manual translation step completely. And that's how they deliver on their goal. Moving beyond the era of static documentation toward an environment where those diagrams are the executable, maintained source of truth for your production code.
That unified vision, it must require a unified platform. And the sources describe the pillars of PivotalAI as a unified cursor-like experience.
I like that phrasing.
Me too, because it implies this seamless, constant interaction across data, AI, and visuals. Like a single cursor is just moving through all of them at once.
And the 3 pillars, the data grid, the AI assistant, and the visualizer, they are designed to be intrinsically linked. A change in one has to affect the others in real time. That's the only way to get that unified cursor feeling.
Okay, let's start with the data grid. This is billed in the deck as the Excel killer.
It's a huge claim.
A huge claim. Excel is everywhere in the enterprise. So what specific capabilities does it have that lets it even compete beyond the basics of, supporting strings and numbers and formulas?
That's a great question. Because Excel is so entrenched, the data grid certainly keeps the familiarity of a spreadsheet interface, but it's radically different underneath. It has reactive state management, meaning changes propagate instantly across the entire platform. If you change a number, any links, diagrams, or reports update immediately. It also has Airtable-style sync capability, so it's fundamentally connected to your other project components. It acts as a dynamic data source, not a static file.
So if I change the projected budget for Region Delta in the grid,
Mm-hmm.
the visualization of that budget in my quarterly report updates immediately.
Hmm.
Maybe the constraint in the infrastructure designer even gets triggered if I go over budget.
Exactly. It breaks that old pattern of import data, process it, and then have to re-import or rerun everything when the source data changes. But the thing that truly makes it AI native is its full AI context awareness.
Okay, let's unpack that. If I'm an analyst looking at a huge spreadsheet, what does AI context awareness actually do for me that a standard database view doesn't?
Well, a standard database view only understands schema, right?
Yes.
It knows column A is a string and column B is an integer. AI context awareness means the AI assistant understands the meaning, the relationships, and the business logic in the data structure itself. It doesn't just see cells and numbers, it sees Q4 revenue targets or customer IDs linked to deployment regions that should be treated as sensitive.
And how does it get that context?
It's derived through a mix of initial analysis and user input. The AI can infer some relationships, and then when a user defines a calculated field or a security scope, that metadata becomes part of the data grid's reactive state. This context is absolutely essential for the AI assistant to work properly, especially when it's translating natural language queries into things like SQL.
That makes sense. That data grid context leads us right into the AI assistant, the intelligence layer that powers the whole experience. The sources specify the engine here is Gemini 2.5.
Yes, and using a leading model like Gemini 2.5 sets a very high bar for complex reasoning. And that's vital when you're asking an agent to generate valid HCL or optimize a workflow. The assistant has to be reliable, not, creative.
So what are the core functions that are tailored for enterprise users here?
First, the fundamentals. Natural language querying. You should be able to ask complex business questions like, which deployment zones have seen a security patch failure in the last 72 hours, without needing to know SQL.
Okay.
Second, automated data analysis. The AI can process the data grid and look for patterns, anomalies, or trends on its own based on the context it has, freeing up the user from all that manual filtering.
But the truly transformative part, the part that ties back to that unified cursor-like experience, is how it interacts with the UI itself.
Absolutely. This is where the agent really earns its name. Control over the UI via prompts. You can prompt the AI to not just give you an answer, but to perform an action on the visual canvases. Like, generate a new flowchart for the updated disaster recovery process, or display the EC2 instance count in the infrastructure designer and highlight any that are tagged as high risk.
So it's a co-pilot that can actually manipulate the visual elements, but it respects the constraints of the design tools.
Correct. And this is critical for the infrastructure and workflow designers. It features multimodal understanding. As we saw in the architecture notes, this engine can understand complex, graph-like structures and visual flow relationships. It's not just limited to tabular data.
And that multimodal ability is what allows it to correctly translate a decision node in a flowchart into clean code, or connected cloud icons into valid dependency blocks in HCL.
Exactly.
Okay, let's look at the third pillar, the visualizer, which the deck calls intelligent charts. This is how the system uses that AI context to make visualization dynamic and insightful, not just static graphs.
The key here is that connection back to the data grid and the real-time state management. The visualizer offers dynamic chart generation with real-time updates. Data point changes, the visualization changes instantly. No refreshing, no re-exporting.
And it supports the standard stuff.
Yeah, bar, line, area, and pie charts, the usual suspects.
But the intelligent part is where the AI takes charge, right? Suggesting better ways to look at the data.
Exactly. The AI plays two critical roles here. First, AI-selected visualization types. For a given data set, the AI suggests the most appropriate way to display it. Second, auto-configuration suggestions, helping you refine the presentation, pick the right axes, or filter outliers.
We have a fantastic specific example of this from the source material. the live pulse dashboard image.
That image is incredibly detailed. It shows a dashboard with real-time metrics flowing in. $2.4 million in revenue, 47.2 thousand active users.
A 3.2% conversion rate. It's clearly handling complex, real-time data pulls.
Right, and you can see a revenue trend chart and a pie chart by region.
But the most important part of that screenshot, the element that really sells the intelligence of the platform, is right there at the bottom, the AI suggestion box.
That suggestion box, based on the context of the conversion data it's analyzing, doesn't just suggest a bigger bar chart. It says, and I'm quoting, "Try a Sankey diagram to visualize customer flow between stages."
Let's pause on that for a second. Why is that Sankey diagram suggestion so telling?
Because a Sankey diagram is not your default choice for a quick report. It's a complex flow diagram used to visualize the magnitude of flow between nodes in a system. It's perfect for tracking customer journeys, seeing where users drop off in a funnel, or how budget flows through different departments.
So the fact that the AI suggests this specific, complex visualization, understanding that the current data implies a sequential flow problem.
It showcases its deep contextual awareness in action. It's moving beyond just telling you what the numbers are to suggesting how you should architect your understanding of the process itself. And this brings us to the absolute core technical innovation of PivotalAI v2.1, the agent-native transformation. We need to be really clear here.
Yeah.
This isn't just about making pretty pictures. This is how the platform actually turns those visual ideas into maintainable, production-ready code. The definition of agent native in practice is that the visual artifact is the logic and the code structure ready for execution.
So we're talking about two massive generative capabilities that just eliminate that translation debt. Flowcharts turning into logic code and diagrams turning into infrastructure as code.
That's it.
Let's start with the logic flows, the visual workflow engine.
So the purpose here is to design complex logic flows visually and then instantly export them for documentation and agent execution logic.
What's the foundation? What is it built on?
The technical foundation is a drag-and-drop canvas built using React Flow, and that choice is strategic. React Flow isn't just a simple drawing tool, it's a modern production-grade graph library. It's known for being really extensible.
So that future-proofs the platform. They can easily add custom node types for specialized agents or other enterprise actions down the line.
Exactly.
And what are the basic building blocks available right now?
You have the standard set you'd need for logical design. You've got start and end nodes, process nodes for discrete actions, the critical decision node for branching logic like if and else, and a DB node to show where the process hits a database.
Okay, so it's got the fundamentals for anyone to map out a process. But the real transformation happens with what they call real-time transpilation. The moment I finish drawing my flowchart, what happens?
It is instantly converted into maintainable Mermaid syntax.
Mermaid, for those who don't know.
Mermaid is a markdown-based diagramming tool. It's super popular in developer communities because it's just plain text, it's easy to read, and most importantly, you can version control it using Git.
So if a process owner draws a complex customer onboarding flow, the documentation is generated instantly in a format that developers can check into Git right alongside the production code.
Which guarantees the logic and the documentation are always in sync. This just eliminates a massive documentation bottleneck.
And the sources mention a split-pane code preview, right?
Yes, a critical feature. You see the visual diagram on one side instantly updating the generated Mermaid code on the other. Plus, the platform includes AI-assisted flow optimization powered by Gemini. The AI reviews your drawn flow and suggests ways to refine or simplify the logic visually before it becomes code.
So the AI is acting like a logic editor, looking for, say, a redundant step or overly complex branching that could be a nightmare to maintain later.
Exactly. It's making sure the visual design adheres to solid engineering principles, rather than just being a free-form drawing.
Okay, so if the workflow engine is important for logic, the infrastructure designer, this feels like the biggest technical shift in the whole platform.
I agree.
This moves from a drag-and-drop sketch directly to production-ready infrastructure as code. This is the diagram to Terraform HCL conversion.
It democratizes cloud architecture design, but it also creates some really significant technical challenges they have to solve.
And the roadmap shows this part is slated for Q2 2026.
Which is realistic given the complexity. The core functionality is to let you visually design your infrastructure and have the platform generate valid Terraform HCL.
So how does it start? How does it handle the architecture?
First, they provide a full component library for drawing cloud architectures. With detailed icons for AWS, Azure, and GCP, a user just drags components onto the canvas. an EC2 instance, an RDS database, a virtual network gateway.
Okay, let's get into the technical depth.
Hmm.
When I drag an EC2 instance on there, the platform needs to know more than just this is an EC2 instance. How does it handle the configuration without me manually typing everything?
This is where the automation is key. The platform handles resource property configuration automatically. And it doesn't just rely on the AI guessing, because that would be risky.
Right.
Instead, the UI presents structured input fields for the core mandatory properties, like instance type, region, security groups. But it can use the AI assistant to suggest optimal defaults based on what's around it and any enterprise best practices it already knows.
That structured input ensures validity. But the really hard part of Terraform is always dependencies.
You hit the nail on the head. This platform automates dependency relationship mapping. So when you draw a connection line from the EC2 instance to the RDS database, it doesn't just draw a line.
It understands what that line means.
It understands that the EC2 instance has to wait for the RDS instance to be provisioned, and that it needs the correct security group ingress rules to talk to the database securely.
So the HCL output will have the required dependent blocks, the security group rules, maybe output variables linking the resources, all written correctly. That alone would save DevOps engineers from manually tracking dozens of resource IDs.
Precisely. The system manages the structural integrity of the architecture, and on top of that, it includes essential validation and error checking. It checks for missing properties or invalid dependencies before anything is deployed.
So if I try to deploy a public-facing database without the right security group,
The visualizer flags that architectural violation instantly. It acts like an architecturally aware linting tool.
so the output is production-ready HCL syntax generation. But how is PivotalAI handling Terraform state management? That's, critical for any production environment.
The source materials strongly imply a standard production setup. For the platform to manage and sync code across users, the HCL it generates has to be designed to use remote backends, like an S3 bucket or Terraform cloud.
Okay.
The design focus is on generating the HCL config, the main.tf files, which an existing enterprise CI/CD pipeline would then execute and manage the state for. So PivotalAI is shifting the engineer's workload upstream.
From writing code to validating the visual design and the automatically generated configuration files.
Exactly. That analogy we used earlier, computer-aided design or CAD, it really nails it. It shifts the engineer from worrying about syntax and boilerplate to worrying about best practices and architectural efficiency, all inside a visual paradigm.
That ability to abstract away complexity means this platform isn't just for one siloed role, is it? It seems to span the entire organization. OffsideAI is really emphasizing that cross-functional value.
They are. The sources outline a very deliberate cross-section of enterprise users. This is a system for coordination just as much as it is for creation.
Let's start with the system architect. Their main pain point is that architectural drift and the slow validation cycles.
For them, the value is immediate validation and better communication. They can sketch system flows and visualize a complex architecture in minutes using the infrastructure designer. And critically, they can use those validation features to ensure the design adheres to cost and compliance rules before an engineer ever starts coding.
So they can iterate on ideas instantly instead of waiting days for a proof of concept deployment.
Exactly.
Okay, next, the DevOps engineer, the person who's usually doing the manual labor of writing all that IAC.
Their workflow shift is just massive. The use case quoted for them is so simple and powerful. I drag EC2 instances, connect to RDS, and export production-ready Terraform.
So they spend their time reviewing the generated HCL for security optimizations and cost controls, not wrestling with syntax and dependency errors.
Right. It abstracts them into more of an auditing and optimization role.
Now let's move to the business side, the product manager. They care about rapid reporting and communication.
The PM focuses entirely on output and the speed of insight. They're generating executive-ready PDF reports, like the Q4 revenue report example, complete with live charts, architecture diagrams, and AI summaries. The automated documentation feature makes this a one-click process.
No more tedious, error-prone assembly of quarterly reports.
But none of.
Then we have the data scientist, who needs advanced analysis but, hates complex BI tooling.
They're going to rely heavily on the AI assistant and the visualizer's context awareness. The AI suggests optimal visualization types for their complex datasets, like that Sankey diagram pushing them toward better insights. They spend less time wrestling with configuration and more time analyzing actual trends.
The sales manager is an interesting one to include. It really emphasizes the platform's connection to proprietary data for just day-to-day operations.
Yeah, they use the platform as a sophisticated zero-training BI tool. The use case is asking for the top 10 customers by revenue growth and getting an answer directly from their CRM, like Salesforce, just using natural language. They bypass the need to know how the CRM data model is structured at all.
And finally, the compliance officer. This highlights the security and governance layer that has to be embedded into this whole process.
This is absolutely non-negotiable for enterprise adoption. The compliance officer can define security requirements directly in the system visual controls that enforce rules like establishing read-only scopes or mandatory column-level masking for PII data.
So governance is embedded at the design phase, not bolted on at the end.
Exactly. It ensures that even when the AI assistant is querying data or generating deployment configs, sensitive information stays protected and access is strictly controlled.
Okay, since the AI is querying all this proprietary enterprise data, security and trust are just paramount. How do they handle that?
The sources address this by focusing on providing privacy-preserving conversations. And they do that through a very specific architecture involving what they call the MCP and R flow. This is how they ensure compliance while using a public model like Gemini 2.5.
So let's detail the steps for a secure query,
Yeah.
because this is where a technical audience needs assurance that their data isn't being exposed.
It follows a distinct four-step flow that creates a really robust security perimeter. Step 1 is the user query. The user just types their natural language question into the AI assistant.
Okay.
Step 2, the RAG adapter. This component immediately translates that natural language into a structured executable SQL query. It's doing text-to-SQL translation. This is crucial because the LLM only ever interacts with the query language, never the raw data.
So the language model itself never sees the customer records or the sensitive figures.
Exactly. The RAG adapter is the shield. Step 3 is the MCP connector. The documentation is a bit vague, but we can frame it as the secure gateway. It handles authentication, authorization, and most critically, it enforces all those security controls the compliance officer defined, like the read-only scopes and column masking, before the query ever leaves the application boundary.
So that MCP connector is the final check, making sure even a valid SQL query can't access masked data.
Correct. And step 4 is where the data actually resides. Your data sitting securely in a private VPC. The query only hits the data after being filtered, sanitized, and authorized.
Which data sources does PivotalAI support for this?
The list is pretty comprehensive. PostgreSQL, MySQL, Snowflake, Salesforce, and Google Analytics. It covers traditional databases, cloud data warehouses, and key sauce tools.
And just to reiterate those critical security controls that govern the whole connection.
These are the non-negotiables. Read-only scopes, so the agents can only fetch, not modify, data. Column masking to hide sensitive PII. And the fundamental requirement of VPC deployment, ensuring everything remains within the enterprise's private network. So we've covered the vision, the components, the users. Now let's pivot to the technical architecture. Developers, engineers, CTOs, they need to know this platform is built for extensibility and serious enterprise scale.
Right. Let's start with the technical architecture highlights. What are the main technologies that are actually underpinning this unified cursor-like experience?
So the visual layer relies on several modern specialized libraries. We mentioned React Flow for the canvas, and diagramming its extensibility is key. For reporting, they use JS-PDF for PDF generation and HTML2 Canvas for reliable DOM capture to make sure the reports are polished and accurate.
And the icons.
React icons are used specifically to provide those essential up-to-date cloud icon sets for AWS, Azure, and GCP.
Okay, that stack confirms it's built on modern interactive tech. Now, what about the data model? If these diagrams are truly source-class citizens, they can't just be generic file types. They must have their own formats that hold all that context.
Absolutely. The system needs to save the intent of the design, not just the pixels. They introduced 3 key proprietary project types to do this.
First up, .piv.
That's the pivotal sheet. It represents the data grid, and it saves not just the raw data, but its internal reactive state, its formulas, and most importantly, all the AI context tags and security scopes associated with the data.
Second, .flow.
This is the Mermaid Flow file. It captures the logical workflow, all the node and edge relationships, the parameters for each process, and the configurations needed for that instant translation into Mermaid.
And finally, .tf graph.
The infrastructure graph. This is the most complex one. The file contains the visual architecture, the resource properties the user entered, and that crucial dependency mapping. This structured data is the foundation for accurate HCL generation and validation.
And let's go back to the intelligence layer itself. Why the specific choice of Gemini 2.5 FAL-Age? Why Flash over Pro or Ultra?
This is a really strategic choice focused on enterprise performance and cost. Gemini Pro is great for, deep philosophical reasoning, but Flash is optimized for speed and low latency.
What you need for real-time code generation.
Exactly. For tasks like real-time HCL syntax generation, text-to-SQL translation, and immediate flow optimization, latency is everything. The system prioritizes being fast and efficient for high-volume, real-time tasks over the kind of deep, reflective reasoning you might need for creative content.
That makes perfect sense. The system needs to be fast and reliably correct, not creative.
And the platform has crucial technical upgrades to support this. We talked about its multimodal context, letting it understand graph-like structures, and they rely on enhanced prompts that are specifically tuned for strict, production-ready HCL and Mermaid syntax, ensuring the output is always valid.
Understanding the architecture gives us confidence. So looking at the roadmap should give us insight into their strategic plan. It looks like they're taking a very deliberate, phased approach here.
They have to, given the ambitious goal of getting into IAC generation. They've broken the deployment into 3 key phases.
Phase 1, Visualization Engine. This is listed as in progress and aligns with their Q1 2026 goals.
This phase is all about proving the core workflow capability. The milestones are the flowchart to Mermaid Canvas, the UI for creating nodes and edges, the real-time preview, and the AI-assisted optimization. They're prioritizing the foundational workflow and documentation first to generate early value.
Phase 2, Infrastructure Logic. This is planned for Q2 2026. This is where the heavy-hitting ISE features arrive.
This is the pivotal phase for technical users. It includes building that big cloud icon library for AWS, Azure, and GCP, developing the graph to HCL translation layer, and implementing robust dependency validation. This is what transforms them from a workflow tool into a full infrastructure as code generation tool.
And Phase 3, Reporting in Polish. This is about enterprise-level delivery and refinement.
Right. This focuses on the presentation layer and hardening the system. It includes the WSIYG PDF builder for executive reporting, custom branding support, UI refinements, and critical performance optimization to make sure it can scale. This phase finalizes that whole automated documentation feature.
And before we move to our final takeaway, let's just quickly touch on the credibility of the team behind this. Who actually built OffsideAI?
The material really emphasizes that this is a world-class team. Over 50 combined years in AML, 15-plus research publications, 8 ex-FANG engineers from places like Google, Meta, OpenAI, Stripe, and Databricks, and 3 successful exits.
So this is not some small aspirational startup.
No, this is a highly experienced, specialized team aiming for a fundamental, scalable shift in enterprise development. They know the difference between a cool prototype and a production-grade system.
So if we bring this all together, PivotalAI v2.1 is really positioning itself as this critical link in the enterprise development chain. It's the platform that lets teams move seamlessly from ideation and secure data analysis
to visual workflow and infrastructure design.
all the way to production code and deployed infrastructure. And all of it happens inside this one unified, secure, and highly intelligent AI-aware environment.
The core value proposition, as OffsideAI sees it, is just ending the era of disconnected tools and static documentation. By treating those visual artifacts as executable, maintainable code foundations, they speed up time to market and drastically reduce the context switching and manual errors that plague modern development teams.
Shifting the focus from that manual translation to high-level architectural design.
Exactly.
It's an ambitious vision, one that leverages the best of modern generative AI to fundamentally change how architects and engineers interact with their systems.
If we connect this to the bigger picture, this kind of system where the visual diagram is the source of truth, it fundamentally changes the role of the engineer and the architect. It shifts them from being writers of low-level configuration syntax to being designers of high-level systems. And this raises an important question for you, the listener. If the AI handles the translation and generation of all that complex HCL or Mermaid code, how will your team measure and maintain ownership of the underlying technical execution moving forward? Is ownership about knowing every single line of generated code, or is it about owning the high-level visual and governable design that enforces those execution rules? That is the structural challenge moving forward into the age of agent-native platforms.